Welcome to Study Loop.
This is problem 105 for vector mechanics for engineers, statics, and dynamics. So in this problem, there's a cable stretching from A to E. There's a load applied downward at B, which is just labeled Q. There's a load applied downward at C, which is 120 kilonewtons, and a load applied at D in the positive X direction, just labeled P. So the horizontal distance from A to B is 4 meters, from B to C is 4 meters, C to D is 4 meters, and D to E is 4 meters. The vertical distance from A to E is 2 meters, from A to B is 3 meters, and from B to C is 2 meters. So our task for this problem is to find P and Q to maintain equilibrium in this problem. So we're going to start off with drawing a free body diagram from D to E, and we're going to include the reaction forces at E. EY is in the positive Y direction, and EX is in the positive X direction. So we're going to start off with taking the summation of moments around D and setting that equal to 0. So this will be positive EY times 4 because there's 4 meters in the horizontal direction between D and E. We're going to subtract EX times 5 because there's 5 meters in the vertical direction between D and E. And we're going to go ahead and solve for EY. This is 5 over 4 EX. And we're going to use this equation later on. Next, we're going to draw a free body diagram from C to E. We're going to, again, do the summation, but this time around C. Set it equal to 0. So this will be EY times 8, because there's 8 meters in the horizontal direction between C and E. Minus EX times 7, because there's 7 meters in the vertical direction between C and E. And then minus P times 2, because there's 2 meters in the vertical direction between C and D. And again, set that equal to 0. And next, we're going to plug in this EY equation here and simplify. So this will equal 5 over 4 EX times 8 minus 7 EX. We're going to go ahead and move that 2P to the other side. So now we're going to simplify and solve for EX. EX equals 2 over 3 P. We're going to use this equation later on. All right, and now we're going to draw a free body diagram from B to E. And we're going to take another summation of the moments around B this time, so that equal to 0. So this equals EY times 12, because 12 meters in the horizontal direction between B and E, minus EX times 5, because 5 meters in the vertical direction between B and E, minus 120, the force at P, times 4, because 4 meters in the horizontal direction between C and B, and that's set equal to 0. So we're again going to solve or plug in EY down here. And plug that in there. So this will be 5 over 4 EX times 12 minus 5 EX. And we're going to move the 120 times 4 to the other side, which is 480. So we're going to now plug in this EX equation into these. So simplifying, plugging in 2 over 3 times P for all these EXs, it's going to simplify down to 10P minus 10 over 3P equals 480. And we can go ahead and solve for P now. P equals 72 kilonewtons. So that is 1/2 of the problem, or 1/2 of the solution. Right? We're now going to do a free body diagram for the whole entire thing from A to E. We're going to include the reaction forces at A. AY is in the positive Y direction, and AX is in the negative X direction. We're going to do the summation of moments around A, set equal to 0. So it's negative Q times 4 because there's 4 meters in the horizontal direction between A and B. I'm going to subtract 120, which is the force at C, times 8 because there's 8 meters in the horizontal direction between A and C, plus 72, which is the force of P, and that will be times 3 because there's 3 meters in the vertical direction between A and D, plus EY times 16 because there's 16 meters in the horizontal direction between A and E, minus EX times 2 because there's 2 meters in the vertical direction between A and E, and set that equal to 0. So we're just going to, like we did before, we're going to sub in the equations that we saw for EX and EY to this equation and simplify for one last time. So EX, I'm just going to do it by hand here. EX was 2 over 3P, which by itself is 2 over 3 times 72, because that's what we found above. All right, we can go ahead and plug that into this equation. And again, I'll just put this down here. EY was 5 over 4 EX. So once we plug both these equations back in here and solve down, we are ready to solve for Q. It's going to be negative 4Q minus 960 plus 3P plus 40 over 3P minus 4 over 3P equal to 0. We can plug in 72 kilonewtons for P, and we can solve for Q. So Q is 30 kilonewtons. And these are the two answers for problem 105. So P equals 72 kilonewtons and Q equals 30 kilonewtons.